Hello everyone, we're going to present our integrative project, which is an Abpb. Abpb is a concept made by us that stands for Automated Bulk Product Bagger, called Unipak.
Our main goal is to replicate all the efficiency of a bagger sealer on the industry into a compact machine more suitable for the general stores. Our team members are
Hi, my name is Isaac, and I'm part of the design department in the development of Unipak machine.
Hello, my name is Martin Felix, and I'm also part of the design department in the development of Unipak machine.
Hello, my name is Fernando, and I'm part of the control department in the development of Unipak machine.
Hello, my name is Adrian, and I'm part of the control department in the development of Unipak machine, but also I'm the leader of the project.
Hello, my name is Cesar Ivan, and I'm part of the manufacturing department in the development of Unipak machine.
Hello, my name is Alonso Madera, and I am part of the manufacturing department in the development of Unipak machine.
We saw that in the industry a lot of thermal sealers already exist, and we wanted to take the main idea of this type of machinery and take it to the local stores into a reduced cost and space product.
We previously developed a machine of this type, but we simply couldn't achieve the goal on its own or to the totality due to a lot of inconveniences with building it. So as money related and also material related components needed at that time were out of existence or simply just too expensive.
First version. In the past September-December 2019 term, we designed a thermal sealer machine for bulk products, where you can control how much product the machine will seal based on its weight. This machine worked with a gear transmission. As you can see in this video, the driving gear and the hopper had a hole where the bulk product flow when they match position. Once the required weight was on the back, which was measured by the load sensor, the two motors connect to a rack gear transmission, seal the back, finishing the process. However, the limitations of this machine were massive in comparison to the industry needs. Its limited storage, along with the fact that you had to change the bags manually and the structural stability of the machine, were a formula to disaster. So, we worked the project of this machine to overcome these limitations and create the ultimate thermal sealer machine of bulk products. Thermal sealer development. The thermal sealer only went through two stages of development. For the first design, we planned to seal the bags using a simple gear transmission, where each part of the sealer were attached to a gear. This way, the system seal and pull the bag once both parts of the sealer meet per revolution, sealing the bag and pulling more plastic tube to pack the next bag. This idea was scrapped because the system was too bulky to fit in the machine, and because it was impossible to cut the plastic tube in bags. The second and most recent design is a pneumatic sealer, which has a blade between two heated pieces of metal, pushing the plastic tube to a wall where the bag gets sealed and cut, making it lighter, easy and simple to activate. This design for the sealer stayed even though other parts of the machine were changed.
Hopper's development. The hopper is a part of the machine which went through a lot of changes, having around 4 versions of it. The first design is based on the first iteration of the dispenser part of the machine. This version was scrapped in early development because we weren't able to figure where the motor was going to be attached. The second design works as a sliding moved by a mechanical joint acting as a crank, which allows or obstructs the flow of bulk product. This idea seemed ideal and ingenious. However, this idea was scrapped because the way you attach the actuator to the system were too bulky. For the third design, we went for the simple. We decided to attach the motor directly to the latch, each container allowing or obstructing the flow of bulk products. We only have one major problem, because we use one motor per container, and we used 6 containers, we had too many motors on the machine. This increased the electric consumption on the machine and the cost of it. This was impractical, so the idea was scrapped and made the most recent design. The fourth design works the same as the first design and the first machine. A gear with a hole attached to a chute with 4 holes, one for each product, which allows the selected flow of bulk product depending on where the hole and the gear matches. Sealer bag. A belt of 762 mm longitude driven by 2 gears of 120 mm of diameter extracts the necessary amount of sealed plastic bag depending on how much product is going to be packed. This is controlled by 4 motor control strapper to give precision on each millimeter of plastic bag extracted. This element stayed the same through all the iterations of this machine. Final measures. On the recent iteration of the machine has the following measures: 200 centimeters by 620 centimeters by 448 centimeters, making it compact, complete, and structurally stable.
Hello, my name is Alonso Madera, and I am part of the manufacture team in the development of Unipak machine. I'm going to explain one of the processes that we're going to make usage of in order for us to make the main mechanism. So quickly, here's some of the code that we're going to make usage of in order for us to CNC machine our gears fully custom made, and as you can tell, it is divided into different areas of the CNC machining processing, and we made this possible with the SolidWorks function of coding. Also, we have almost 2000 lines of codes, and if you know something about the G code, feel free to pause the video and take a quick check on it. But the main functions that we use are G21 and G28, since these ones allow us to fully measure as a work area so that the gear doesn't go oversized or undersized. CNC machining. This basically to make a set of gears that will make the mechanism of selection of the product into a simpler way, and also do that we need a specific type of gear that is not found in the market. We decided to make the main gears of the machine out of aluminum 6061 T6. That is one of the most commercial aluminums with high machinability capacity and also has high mechanical resistance. That is one of the most important things here, because the machine is going to be with a lot of weight on it. Also, we're making usage of 3 main spindles: one DIN 4974 of 10 mm, one DIN 6535, and one upcut of 1.5 mm. Also, quick note is that when we are going to machine off the gears made out of lineamid, we use different velocities due to the mechanical properties of this type of material is different. The main frame of the machine is made out of aluminum of group 2000. This is because it has a high mechanical resistance but a low corrosion resistance. This last type of low corrosion resistance are going to have a special paint treatment to compensate this low resistance. Also, for the mechanism that is going to have direct contact with the food, we are going to use 3 FDA approved materials: high impact polystyrene sheets. This is the cone that my partner is going to explain later, and also we're going to use Nylamid type M and Decathlon PFTA. This is because these 2 materials provide that security that we wanted to make to reduce the friction between these plastics, to prevent any type of combustion, and also because these materials does not affect the food taste at all. And finally, we are going to make usage of some stainless steel 316 rods for the bag mechanism. This is for the bag that is going to be in constant rolling, and also this stainless steel is FDA approved, so basically the bags are not going to contain any type of toxicity on it.
It exists 3 types of painting process: monolayer, bilayer, and 3-layer. These are used for different purposes. The one we are using for our machine is the bilayer painting, due to its utilization in the automotive industry. One of the reasons we're using this is because the materials we're using are weak to corrosive, and this type of painting helps prevent it. The paint we're using, it is food safe grade. For welding the main structure, we're using the small process. It's a manual arc welding process that uses a consumable electrode covered with a flux to lay the weld. We are using it due to the material, it is space grade aluminum. The process is primarily used to weld iron and steels, including stainless steel. But aluminum, nickel, and copper alloys can also be welded using this method, and due to working with some of it. The small process is the best for it, and we're using it. A specific welding rod due to its great work under aluminum. We did not find the container specific to our project, and also the main cone for the dispenser. So, we're using the vacuum forming to form our own containers and the main dispenser. The process is simple. We use high-impact polystyrene sheeting, HIPs, food-grade thermoforming plastic to mold our containers. These are also used for butter or even Yakult or Danoninos. The process is simple. We heat the plastic sheet, then we put it in the machine, and finally we turn the vacuum on, and it sucks all the air out, so we're left with the piece we want. Then we cut in it using scissors or some kind of saw. Vacuum forming is done by our part using a vacuum forming machine. To cut the parts for our machine, we're using, for the main tools, a vertical saw, in order to cut down the pieces we need. To cut down the T-slotted aluminum profiles, we need a metal cutting saw with cardboard tip blades from the main cutting disc. We're also using it for cutting the main frame for the machine. I'm showing the main amperage used for some of the materials. We're also using Grillumin 14 for the main electrodes, due to being the perfect welding rods for the small process. It is also specialized for aluminum silicate alloys, so it's perfect for a machine.
We chose the microcontroller Arduino Mega 2560, which is a microcontroller board based on the AT Mega 2560. It has 54 digital input-output pins, of which 15 can be used as PWM outputs, 16 analog inputs, and 4 UART serial ports. Here are some of the reasons why we choose the microcontroller. Low-cost microcontroller. Enough I/O ports to cover all our needs. Programming language, which is C-based. A smaller circuit board than a PLC. Wide variety of module sensors. Low energy consumption. PWM outputs. Sensors. LM35 sensor for temperature reading on the sealers. 10 kg load cell to weigh the product. Optic reflexive infrared sensor to detect the product flow. Limit switch for the back row. Actuators. 5-2 electro valve to control the pneumatic cylinder. Pneumatic cylinder to push the thermal sealer. MG99 6R servo motor to let the products pass to the container. Upper thermal sealer to shape the plastic roll into a bag. Lower thermal sealer to close the bag in both ends. It is in the lower part of the machine. 2 full rotation 25 kg servo motors to control the product selector and the gate so the product can pass. High torque motors for the rollers to pull down the plastic bag. Security elements. On and off switch to turn on and off the machine. Emergency stopwatch to contract the sealing cylinders and cut the current of the machine. Control case where all the control elements are mounted. An energy case where all the supply and related elements are located.
Here we have the electric circuit of the temperature sensor for the thermal sealing part of the project.
It has its own amplification circuit made of two LM334, the first acting as a buffer in order to keep the signal strength, and the second one to amplify the signal, so we can make the reading in volts instead of millivolts.
With this, we are going to save a certain amount of code lines. Here we have the AC dimmer circuit to control the heat in function of the temperature reading.
The amount of heat is the product of the current and voltage, so we're controlling it by using PWM through an IGBT triggered by an optocoupler.
Now, we have the circuit for the stepper motors, the load cells, the temperature sensor, the HMI, the servo motors, and the two thermal sealers.
These are the main circuits on our project. Finally, we end up with a circuit board of 17 by 9 centimeters.
Kilowatts hour consumption. These are the elements that require the most energy of the machine. We have a compressor, one servo motor MG996R, an electro bulb, two thermal sealer, an Arduino Mega 2560, one display connection of 7 inches, two full rotation servo motor, and two high torque motor. At the end of the day, we have a current consumption of 7.085 amperes, and finally we have a total consumption of 287.93 kilowatts hour per month. Process. First, it must be emphasized that it is not a 100% automatic process because there is an interaction between the user with the machine. So that, let's start with the process. First, a menu with the 4 products is going to be displayed on the HMI. After selecting the product, the HMI is going to ask you to select the quantity of product you want or select the amount of money you want to spend. Then, the motor located under the containers rotates the platform to align the selected product. After that, the second motor will open the gate, allowing the product to pass into the load cell. When the weight in the load cell is equal to the chosen value, the motor will be activated again, but this time blocking the passage of product. With this, there is not going to be a foot loss. Then, the side rollers will pull a percentage of the back, and the solenoid valve is going to be activated, in turn activating the piston for the lower sealing of the back. Next, a signal will activate the rollers and thus the part of the product pack will be below the lower sealing section. So the solenoid valve will open and close the piston to seal and cut the top of the back, giving you a sealed back with the amount of product you selected.
So, as you can see, with all the development of the machine, we've come across a suitable, more economic machine capable of making an impulse to all the small business out there.
There is a lot of competition when it comes to the bulk food ingredients market, but with our machine, we estimate a suitable profit compared to the manual bagging process.
We estimate that the profit annually when making the process manually is around $31,320 United States dollars, but with Unipak, that profit goes up to $187,920 United States dollars, based on the previous market of bulk products in Mexico.
Made research on all the materials to provide all the quality and capability of an industrial machine in the form of a machine for local business, and we came across the conclusion of a machine value on 60,265 Mexican pesos.
With this, we offer opportunities for all the smart entrepreneurs to start with the right foot on their journey to succeed in one of the most competitive food markets out there.
We want to create an easy and effective, no time training, no pollution maker, easy to use machine. High opportunities, low risk, we are Unipak.